Poisson distribution. A Poisson distribution is the limiting case of binomial distribution. In Poisson distribution, number of trials go to infinity, probability of success go to 0, okay, but NP is equal to M, which is a finite constant, okay. So N, you know, this is the number of trials, P is the probability of success. For binomial distribution, Px is equal to NCx, P to the power x, Q to the power n minus x, and P0 is Q to the power n. Therefore, limit of n tends to infinity, P0 is equal to limit of n tends to infinity, Q to the power n, which is equivalent of saying 1 minus P to the power n which is equivalent of saying 1 minus m by n to the power n. Why m by n? You know this, that np equals to m. I need to get the value for p. Now np upon n is same as p, and np is m by n. So you can write this also as this way. Well, this limit, okay, this is limit of 1 minus x to the power n, and when n goes to infinity, it is given by e to the power minus m. Okay, so now you guys know this, that px plus 1 upon px for binomial distribution. In case if you haven't seen the recurrence formula for binomial distribution, I would urge you guys to see and go back to that recording, which is nc x plus 1 px plus 1 q to the power n minus x minus 1 upon ncx p to the power x q to the power n minus x, which could be written as n minus x upon x plus 1 into p by q. Okay, now if you take up limit of this, that is limit of n tends to infinity, px plus 1 upon px would be equal to limit of n tends to infinity, n minus x upon x plus 1, and for p by q, what you can write, p you can write as m by n, then of course q you can write as 1 minus m by n. Is that okay? Which is equivalent of limit of n tends to infinity 1 minus x by n upon 1 minus m by n into m upon x plus 1. Okay, so at the end of the day, and where n tends to infinity, so this will become what, 0, this will become what, 0. So what you will have is just m upon x plus 1. So in fact you can write as limit of n tends to infinity px plus 1 upon px is equal to m upon x plus 1. Okay, well, one more thing, you can write px as px upon px minus 1, okay, into px minus 1 upon px minus 2, and so on to p1 upon p0 into p0. Okay, all of this will get cancelled out and you will have this. So taking limit of all this, so taking limit taking limit when n tends to infinity and using these. Let me name these things. The first one is this, okay, limit of n tends to infinity 1 minus m by n to the power n, and this one, which is 2 here, is this. Yeah, so limit of n tends to infinity and using 1 and 2, you can write limit of n tends to infinity px is equal to m by x. See, this could be written as then m by x. See, px plus 1 upon px was written as m upon x plus 1. Okay, px upon px minus 1 would be written as m upon x. Px minus 1 upon x minus 2 would be written as m upon x minus 1, and so on to m upon 1 into p0 is written as e to the power minus m. Note that limit of n tends to infinity is put over all of these factors. Okay, so all of these px upon px minus 1, px minus 1 upon px minus 2, on all of them this limit has been put up. So, and what you will find is that these m is being multiplied x times. Okay, these m is multiplied x times, m to the power x then into e to the power minus 1. What is this? X into x minus 1 into x minus 2 to 1 is x factorial. Fine. So what did you find out? The probability of x successes is given by px, which is e to the power minus m into m to the power x upon x factorial, where x is equal to 0, 1, and so on to n. In fact, to infinity. Now this is called Poisson distribution. This is called Poisson distribution of the variate x, and m is called its parameter. Okay, and the variate x is called the Poisson variate, and this x is called the Poisson variate. Okay, and you write it as x is distributed as Poisson with parameter m. Is that okay? So this is what your Poisson distribution is. Okay, this is a limiting case of binomial distribution. You have to see whether this constant np is a constant 1, n is tending towards infinity, and p is tending towards 0. It's a classic example is like the number of errors in a page of a book. Okay, so you have huge number of words, and the amount of the error which you have is very less. So n is tending towards infinity and p is tending towards 0. So that's the case of Poisson distribution.